Okay, we're going to be looking at the 5.1 assignment, and I'm going to go ahead and work through the evens with you to help you a little bit, just in case you're kind of struggling with some of the vocabulary or visualizing what's happening in this assignment, okay? So again, I'm going to work evens. That will keep you doing odds on your own. All right, so I'm starting with question number, no, I'm doing odds, aren't I? I'm doing odds and not even, so I'm trying to remember what my student asked for. Yeah, that's right. So I'm just kidding. I'm going to do odds, not evens. You do evens, I'll do odds. How about that? All right, starting with number 1. It says, what are 2 other ways to name line EF? So here's line EF running through the middle of this plane. And remember, we can name lines either with a lowercase letter if it's given. There's not one given in this problem because if you look outside of the arrows, you don't see anything. Or we name a line with 2 points on the line. Remember, EF and FE are the same line. So I'm wanting you to incorporate the letter B in this problem. So you could say something like EB, or you could say BF. And that would be 2 other ways to name this line. Okay, looking at number 3, it says name 3 collinear points. 3 collinear points. So collinear means together on the same line. So I'm looking for 3 points together on the same line. I see 2 lines, this guy right here and this guy right here. Can't name 3 points on M because I only see 1 point, but I can name the 3 points on this line. So my answer would be points E, B, and F. All right, question number 5. Question number 5. I am wanting you to name the segments in the figure, and there's tons of them. And if you miss some, it happens. So I'm going to just start with R. Remember, because it is a segment, it is measurable. If it is a different length, it is a different segment. So I'm going to start with R. RS is the first one that I see. So R to S. And then R to T, right? So this segment right here is a different segment. So RT. And then RW is yet another segment because it is another length. So these segments are measurable. So those are all the ones for R, but there are some that start with S, or that have S as the beginning or the end, depending on if you're looking up or down the line. So ST, for example, would be 1, but not SR because it's the same as RS, right? And then there's another one, SW. And then we can start with T. Kind of got a lot of little segments going on here now. But like TW would be 1. And then really there are no W ones here because WT is the same thing as TW, WS is the same thing as SW, and WR is the same thing as RW. So these would be all my line segments. Okay, when we look at number 7, it says name the pair of opposite endpoints, name the pair of opposite rays with endpoint T. Right, so here is endpoint T. So regardless of, what other one I pick, I know I'm going to have some ray that has endpoint R and some ray that has endpoint R. And so, I don't know why I'm saying R. I'm just crazy on this video. This whole day has been one mistake after another. All right, endpoint T means it should start with T. So T to W would be one ray. T to W is kind of hard to see here. And then remember, opposite rays have the same endpoint, opposite direction. I can either say TS or TR because those are the exact same ray. So I'm just going to say TR. But I could have said TS just as easily. Okay. Let's jump to number 9. It says, name the intersection of the planes ABC and BCG. So the plane ABC A, B, C is going to be the bottom of this rectangular prism or this box here. And ABC is the bottom, so I need the fourth bottom point. And in order to kind of see that, I'm just going to go ahead and shade it like we did in class today. And then we want to intersect that with BCG. So BCG. These are all on the right side, so I need the fourth right side point. And so I'm looking at this side of the box, and I'm going to go ahead and shade that in blue. And you can kind of see here that the bottom and the right side are intersecting at this edge right here, which is going to be line BC. Number 11 says, name two planes that intersect at AE. At AE. So, I may have too much stuff going on this now, but here's AE. Right? Here's AE. So, we know, or we want to think about what faces of this box, or what sides of this box, front, back, left, right, top, bottom, include the edge AE. So, I hope you can kind of see this, but this edge is touching the whole front side, and I'm just going to use the highlighter since I've already colored. So we know it's going to be the front, right? So one of the planes is going to be EAB. EAB. And then another plane, so this side is also connected to the side of the box over here, which is the plane EAD or EAH, however you want to name that. I'm going to go ahead and use the EA, but you could even just do like EHD or EHA or something like that. EAD. So those are the two planes that intersect to create this AE line right here. All right, moving on to number 13. Use the figure to shade the plane that contains the given plane. Interesting. So BFG is the plane that includes these two sides, right? So the plane that includes these two sides would be this right side. Whole thing. So don't do BFG and then draw a line from G to B and just color a triangle, because you've missed part of the plane when you do that. Remember, the plane is the entire flat surface. All right. Then we're looking at EHC. So EH and then C is all the way down here. So we did one like this in class. EHC is going to cut right through the middle of the box. So if I've included the top left edge, then I need to include the bottom right edge. and go right through the box again. And so this is going to be, and I just realized I've worked an even. You're welcome. And so I'll leave the last one for you to do, the DEF. I'll leave that one for you to try on your own. Notice my hint here, if you're kind of struggling with it, is go ahead and connect DE and EF. And notice you went from front to back. And then also notice you've got the front top edge. So you're probably going to need that back bottom edge. Okay? Moving on. So the next section of homework, you were supposed to draw, if possible, draw a figure to fit the description. I will tell you that not all of these are possible. I think there's one that's not possible. So if you feel like it's not possible, it's probably not possible. So if I want to do 4 points that are collinear, remember collinear means on the same line, right? And I can pick anything I want. I'll be really boring and say, here's point A, here's point B, here's point C, here's point D, there's 4 points, and now they're all on the same line together. They are collinear. 18 is 3 points that are not collinear. So I might have like A and B, right? So here's A and B together on a line, but then here's C out here by himself with no friends. I'm going to leave 20 for you to do. I just realized I switched back to evens because I'm a crazy person. So basically what's happening here is I'm randomly working problems on your homework and you're going to work the other ones. I've lost it. I'm going to leave 20 for you to do on your own. It's very difficult. So it's a good challenge. So go ahead and try it. I'll go back to evens just for kicks here. No, I'll go back to odds. Okay, so I'm going to graph the points and decide if they're on the same line. So first point is 1, 1. Second point is 4, 4. Third point is -3, -3. Right? So if they're on the same line, then they will have the same slope from point to point. If they're on the same line, they'll have the same slope from point to point. So I might just draw a line between them to see if I could convince myself that they are. Okay, so they look like they're on the same line. And I'm just going to check the rise over run to see if they are. So right here I rise 1, 2, 3, 4. And I run 1, 2, 3, 4. So the slope from this point to this point is 4 over 4, which is 1. And then I'm going to go point to point again. I rise 1, 2, 3. And I run 1, 2, 3. And 3 divided by 3 is 1 again. So if they have the same slopes from point to point, then they are indeed on the same line. And so we would say, yes, they are collinear. Number 25, last one. We have the point -2, -6. So -2, -6. Next point is 1, -2, so +1, -2 down here. Third point, 4, 1, so 4, 1. Again, they look really close to being collinear. If I sketch a line between them, I could almost convince myself that they are collinear, right? If I use a straight edge, now I have doubts because this guy does not look like he's on the line. He looks like he's close to it, but let's count. Okay, so we're going to do rise over run. So 1, 2, 3, 4. 1, 2, 3. So my slope here is rise over run 4/3. And then again, I go from point to point. I rise 1, 2, 3. I run 1, 2, 3. 3 divided by 3 is 1. So my slope is 1. Because they don't have the same slope, and you can kind of see it when you draw the picture, because there's not the same slope from point to point, they're not on the same line, so they are not collinear. All right, guys, I hope I helped. I'm sorry that I randomly went from evens to odds and worked random problems on the homework. I will see you tomorrow. Have a wonderful night.